When you conduct research about a group of people, it's rarely possible to collect data from every person in that group. Instead, you select a sample. The sample is the group of individuals who will actually participate in the research. To draw valid conclusions from the results, you have to carefully decide how you will select a sample that is representative of the group as a whole. So there are two types of sampling methods. First is the probability sampling. Probability sampling involves random selection, allowing you to make strong statistical inferences about the group. The next is the non-probability sampling. It involves non-random selection based on convenience or other criteria, allowing you to easily collect data. But you have to remember that probability sampling is more powerful than non-probability sampling. But before we will proceed to the specific types of sampling technique, you need to understand first the difference between population and sample. So the population is the entire group that you want to draw conclusions, while the sample is the specific group of individuals that you will collect data. So the population can be defined in terms of geographical location, age, income, and many other characteristics. Like for example, if you want to make inferences about the whole adult population in your community, or patients with a specific health condition, or students in a particular school. So it's very important to carefully define your target population according to the purpose and practicalities of your study. If the population is very large, demographically mixed, and geographically dispersed, it might be difficult to gain access to a representative sample. So the sampling frame is the actual list of individuals that the sample will be drawn from. Ideally, it should include the entire target population. For example, you are doing research on working conditions of employees in a certain institution. Your population is a total of 1,000 employees of that particular institution. So your sampling frame is the institution's database of employees, which lists the names and contact details of every employee of that institution. Of course, when you draw only portion of that population through sampling, you need to compute first the sample size. There are many ways to determine the sample size. So this sample size, these are number of individuals you should include in your sample, depends on various factors. So this particular sample size can be computed using census from smaller population. You can utilize the sample size formula, and there are also a lot of sample size calculators. There are softwares available to compute this sample size. We will now proceed to the different sampling techniques. So we have the probability sampling, which means that every member of the population has a chance of being selected. It is mainly used in quantitative research. If you want to produce results that are representatives of the whole population, then the probability sampling are the most valid choice. There are four main types of probability sampling. We have the simple random sampling, systematic sampling, stratified random sampling, and cluster sampling. In a simple random sample, every member of the population has an equal chance of being selected. Your sampling frame should include the whole population. So to conduct this type of sampling, You can use tools like random number generators or other techniques that are based entirely on chance. In some common ways, we do lottery method when we perform simple random sampling. For example, you want to select a simple random sampling or sample of 100 employees of a certain institution. You assign a number to every employee in that institution's database from 1 to 1000 and use a random number generator, or you can use the lottery method to select the 100 numbers. So that's an example of simple random sampling. Meanwhile, systematic sampling is similar to simple random sampling, but it is usually slightly easier to conduct. So, systematic random sampling involves every member of the population is listed with a number. But instead of randomly generating numbers, individuals are chosen at regular intervals. So that would mean that there is a system of selection for every ant of a population. Example, all employees of the organizations are listed in alphabetical order. From the first 10 numbers, you randomly select a starting point, like for example, the number 10. From number 10 onwards, every 10th person on the list is selected, such as 10, 20, 30, 40, and so on. And you end up with a sample of 100 people. In stratified random sampling, it involves dividing the population into subpopulations that may differ in relevant ways. It allows you to draw more precise conclusions by ensuring that every subgroup or strata is properly represented in the sample. So to use this sampling method, you divide the population into subgroups. As what I have mentioned, it is also called as strata, based on the relevant characteristics such as, for example, gender, the age range, income bracket, or any other characteristic. Then based on the overall proportions of the population, you calculate how many people should be sampled from each subgroup using certain formula or sample size calculator. Then you use random or systematic sampling to select a sample from each subgroup. Example, the organization has 800 female employees and 200 male employees. You want to ensure that the sample reflects the gender balance of the organization. So you sort the population into two strata based on gender. So gender is the characteristic that you wanted to categorize on that particular organization. Then you use random sampling on each group, selecting 80 women, women and 20 men, which give you a representative sample of 100 people. On the other hand, cluster sampling also involves dividing the population into subgroups, but each subgroup should have similar characteristics to the whole sample. Instead of sampling individuals from each subgroup, you randomly select the entire subgroups. So if it is practically possible because of the number of individuals on the selected subgroups, you might include every individual from each sampled cluster. If the cluster themselves are large, as what I have mentioned, you can also sample individuals from within each cluster using one of the techniques that I have mentioned a while ago. This is called as multi-stage sampling. So this method is good for dealing with large and dispersed population, but there is more risk of error in the sample, as there could be substantial differences between clusters. So it's difficult to guarantee that the sampled clusters are really representatives of the whole population. Example, the organization has offices in 10 cities across the country, all with roughly the same number of employees with similar roles. You don't have the capacity to travel to every office to collect your data. So you use random sampling to select three offices, and these three offices, these are your clusters. Now let's proceed to the non-probability sampling methods. In a non-probability sample, individuals are selected based on non-random criteria, and not every individual has a chance of being included. This type of sample is easier and cheaper to access, but it has a higher risk of sampling bias. That means the inferences that you can make about the population are weaker than with probability samples. So as what I have mentioned, probability sampling is more powerful than non-probability sampling, and your conclusions may be more limited. If you use a non-probability sample, you should still aim to make it as a representative of the population as possible. In most cases, non-probability sampling techniques are often used in exploratory and qualitative research. In this type of research, the aim is not to test a hypothesis about a broad population, but to develop an initial understanding of a small or under-researched population. The most common non-probability sampling techniques include convenience sampling, purposive sampling, snowball sampling, and quota sampling. Convenience sampling simply includes the individuals who happen to be the most accessible to the researcher. This is an easy and inexpensive way to gather initial data, but there is no way to tell if the sample is representative of the population, since it is only by the convenience of the researcher, so it can't produce generalizable results. Example, you are researching opinions about student support services in your school. So after each of your classes, you ask your fellow students to complete a survey on the topic. This is a convenient way to gather data. But as you only surveyed students taking the same classes as you at the same level, the sample is not representative of all students at your school. Next is purposive sampling. This is also known as judgment sampling, that involves the researcher using their expertise to select a sample that is most useful to the purposes of the research. So in most cases, purposive sampling has inclusion and exclusion criteria. Like for example, in a community, if you want to survey about the living conditions of those individuals having diabetes, so you can set a criteria that only those individuals with type 2 diabetes will be part of the study. Those without diabetes and other forms of diabetes will not be included in the study. So that particular inclusion criteria will be your basis in selecting the samples. Another is snowball sampling. If the population is hard to access, snowball sampling can be used to recruit participants via other participants. We call this also as referral type of sampling. So the number of people you have access to snowballs as you get in contact with more people, as you have a lot of referrals that you can get from the individuals that you have communicated or you have sampled. Like for example, if you are researching about experiences of homelessness in your city, So you meet one person who agrees to participate in the research, and she puts you in contact with other homeless people that she knows in the area. So that is a referral, and we call that kind of sampling as snowball sampling. Meanwhile, in quota sampling, you select people non-randomly according to some fixed quota. There are two types of quota sampling, which is the proportional and non-proportional. In proportional quota sampling, you want to represent the major characteristics of the population by sampling a proportional amount of each. For example, if you know the population has 40% women and 60% men, and that you want a total sample size of 100, you will continue sampling until you get those percentages, and then you will stop. If you've already got the 40 women for sample, but not the 60 men, you will continue to sample men, but even if legitimate women respondents come along, you will not sample them because you have already met your quota for women. The problem here is that you have to decide the specific characteristics on which you will base the quota. Will it be by gender, age, educational level, race, religion, and some other characteristics? On the other hand, the non-proportional quota sampling is a bit less restrictive. In this method, you specify the minimum number of sampled units you want in each category. Here, you're not concerned with having numbers that match the proportions in the population. Instead, you simply want to have enough to assure that you will be able to talk about even small groups into the population. This method is the non-probabilistic analog of the or equivalent of stratified random sampling, in that it is typically used to assure that smaller groups are adequately represented in your sample.